Okay, and good afternoon and welcome everyone to the second of our series of Gas Industry Awards webinars, this week featuring our finalists in the Product of the Year award category. My name is Adam Gosnold. I'm Managing Director of Morrison or M Group Services Energy Infrastructure Division, but more specifically Morrison Energy Services, the proud sponsor of this award this year. Many of you will probably be familiar with the Morrison Utility Services brand, and that has recently transitioned into two separate entities, Morrison Energy Services and Morrison Water Services. That's to enable us to continue our growth in those respective sectors. Our energy services business is responsible for delivering infrastructure services to the UK gas, electricity, renewable energy markets, and our sponsorship of this category makes perfect sense, with innovation playing such an important part, of course, of the energy sector that we all support as part of the UK's 2050 objectives and, of course, net zero future for ourselves and our future generations. So for this afternoon, then, we'll hear from each of our four finalists in the Product of the Year category of the EUA and IGEM Organised Gas Industry Awards ceremony, which is going to be held next month, due for celebration, in fact, on the 18th of May. Before I introduce our speakers this afternoon, just a few pieces of housekeeping. We'll be taking questions after each of the presenters has finished. To do that, to ask your questions, please use the stage chat line, which is on the right-hand side of your screen as you look at your screens. Today's webinar is being recorded, and you will receive a link to this and indeed receive PDF versions of these slides in the next couple of days. So on to this afternoon's webinar then. There will be four presentations from each of the four finalists for the Product of the Year category. The running order in alphabetical order, no clues there then, will be Dr. Demetrius Onofriou from Copperleaf, Duncan Fisher from Plasson, Alex Stewart from SGN, and finally Andrew Sparks from Synthotech. I'd now like to introduce our first speaker, Dr. Demetrius Onofriou. Demetrius is Director of Customer Experience Operations and joined Copperleaf in July 2018. He holds an IAM certificate in asset management and has a broad range of asset management experience. Demetrius leads a team of UK consultants in the implementation of Copperleaf's value-based decision-making software. He is chair of the IAM Midlands Branch Committee and a member of the BSI AMS 001 Asset Management Committee. No finer body of people, I'm sure. So Demetrius is going to talk about Copperleaf 55, Asset Investment Planning and Management Tool, developed by Copperleaf in collaboration with National Grid. The Copperleaf 55 product supports gas utilities to predict and monetize asset risks, optimize asset interventions, and manage project portfolios across their networks. C55 is used in many of the world's by many of the world's leading electricity, gas and water utilities. In fact, I personally came across C55, or probably a predecessor, with Anglian Water several years ago. So without further ado, I'd like to hand over to Demetrius. Thank you.
Thanks very much, Adam. I'll narrate rather than showing you the slides, and then I can show some slides later.
Thanks, Demetrius.
Okay, no problem. So, just to repeat, my name is Dr. Demetrius Onofriou. So I work at Copperleaf. I'm Director of Customer Experience Operations there. And I'm here to represent the submission for Product of the Year Award for Copperleaf Asset Investment Planning and Management Solution, that's formerly known as C55. So this was developed by Copperleaf Technologies in collaboration, this submission in collaboration with Northern Gas Networks, National Grid Gas Transmission, and SGN. So as Adam mentioned, the Copperleaf Asset Investment Planning and Management Solution supports gas utilities to predict and monetize asset risks, optimize asset interventions, and manage project portfolios across their networks. And our solution is used by many of the world's leading gas, electricity, and water utilities. And some of our gas utilities clients include Rheinenergie in Germany, Fortis BC in Canada, in addition to National Grid Gas in the UK, National Grid Gas in the United States, and PowerCo in New Zealand, just to name a few. So we believe the Copperleaf Asset Investment Planning and Management Solution is a worthy winner of the Product of the Year Award, thanks to the major enhancements that support Ofgem's network output measures and network asset risk metrics calculations for both gas distribution and gas transmission companies. So not only enabling Northern Gas Networks, SGN and National Grid Gas Transmission to predict and monetize asset risks, but also optimize asset interventions and manage project portfolios across their networks. At National Grid, the Copperleaf solution has led to significant efficiencies in the capital project planning process, as it improved the ability to anticipate and manage risks, as well as direct resources more effectively. The solution will help National Grid Gas Transmission deliver its business plan as cost effectively as possible, and contributing to the 4% efficiency goal on capital expenditure, which would save £11 million per year. The solution is also part of a new process that will allow National Grid Gas Transmission to effectively plan and optimise all work to meet its strategic, safety, regulatory and commercial obligations. The Copperleaf solution has been used extensively by Northern Gas Networks and SGN to develop their GD2 regulatory submissions. It's enabled these companies to develop asset investment strategies that consider asset risk, including financial, environmental risk and safety risk, intervention costs and customer outcomes. Incidentally, in its 2019 annual report, SGN commented, one example of a project now in use is the Copperleaf solution, which supports our work on monetized asset risk, and to date has identified £4.9 million worth of benefits. So for the gas distribution side, the Copperleaf solution has allowed automated regulatory norms or NARMs reporting. So for planning, the Copperleaf solution has also been able to has been used to create 5-year notional investment plans based on accurate asset data, and due to the speed of optimization of the investments in the system, it provides the ability to change and review investment programs with relative ease. And in addition to this, Northern Gas Networks is currently expanding its use of the Copperleaf solution through a second phase implementation, which incorporates delivery in GD2. And for AIPM at National Grid Gas Transmission, the Copperleaf solution enabled Grid to develop an integrated end-to-end process, which consisted of 5 key elements or capability areas. So one was asset risk modelling, which is a bottom-up approach, looking at the risks of asset over a long-term horizon and determining what investments need to be made. Project portfolio management was a top-down, where investment sponsors would identify projects, investments to be made, and these to be integrated in a dynamic plan that would then be optimized with delivery constraints, and then we would be able to review this plan through outcome performance management. So if we could take those 5 elements in turn briefly, National Grid Gas Transmission's goal for this end-to-end process was starting off by integrating its asset risk modelling capability with the end-to-end investment planning process. So this is linking asset risk modelling to the portfolio plan, and so changes in scope can be measured by the impact on the outputs, and enable gas transmission to overcome challenges in tracking outputs from strategy through to delivery, for example, monetize risk targets. And from the project portfolio management side, the Copperleaf solution enabled the replacement of multiple spreadsheets for a single version of the truth. And in addition to this, we developed with National Grid workflows to support the sanctioning, its sanctioning and governance process. And these all were linked with an integrated plan, and this is about integrating the teams. So the Copperleaf solution enabled the integration of the various teams, asset modelers, portfolio planners, investment sponsors, and ops and delivery, and provided all these teams with visibility and transparency of information across the organisation. And with all these investments and projects in the Copperleaf solution, it enables National Grid Gas Transmission to optimise these investments to deliver the optimum value against the portfolios of the investments. And optimising these projects or investments can be done against various financial constraints that the organisation may have. For example, financial constraints such as CapEx and OpEx, resource constraints, dependencies such as project timings and outage constraints. And finally, with outcome performance management, National Grid Gas Transmission through the Copperleaf solution is able to manage a business as usual living repository of projects, and it can continuously update those projects as these projects are evolving and delivered, and identify any changes that need to be made to the plan. So re-optimizing the plan based on performance against targets and incentives, and importantly, demonstrating these required outputs to Ofgem, for example, through NARM's forecast versus delivered. So that's in essence the Copperleaf solution that was implemented against those three companies. And so I have a question here. What's the biggest challenge you faced in bringing the product to market? The Copperleaf solution has been around and evolving for a number of years now, and I would say rather than a challenge, one of the big enhancements that we had was the development of a value framework capability as part of the solution, which enabled us to work with these organisations such as Northern Gas Networks and SGN and National Grid Gas Transmission, to work with them to bring in their models into their system, to enable them to calculate their monetised risks, etc., but to integrate that within the investment life cycle. And so the biggest the key to the success of these projects was the effective implementation of value framework, utilising all the organisation's models.
Thanks, Demetrius. And if there are any more questions, please use the stage chat line on the right-hand side of the screen there. So just another couple of questions, I guess, for me then, Demetrius. In the absence of, a lot of these systems require high-quality asset data as a kind of a starting point. And I think it's fair to say that with ageing assets across the industry, not just gas, electricity, water, but wider industries as well, sometimes it's not always possible to get really good quality asset information. So how much does C55 make, if you like, an informed decision-making process on the back of asset data that we input into the system, as opposed to, say, algorithmic assumptions that are made from a much wider industry collection of data and asset performance?
So I think that the key here is not, and we advise all our clients, is not to hang back and say, well, we've got to make sure that all our data is cleansed, etc., before putting it into the system. Actually, the idea here is to work with these organisations such as IGEM, SGN, and National Grid Gas Transmission, because through the implementation and bringing in the data in the state that it is actually highlights the areas that need to be targeted in data quality. And so when, for example, running a first optimization or looking at the value generated by investments, the idea is it's this transparent system where it informs the user to make those decisions. So that is part of the decision-making process. And so taking the example of let's say, poor quality underlying data, it enables the user to say, well, actually, I know there's no way that investment has that value because I know the condition of that asset, what is the underlying issue? And it enables the user to drill in and say, actually, it turns out the asset data that's been used to inform this is old, so it needs updating, or the way that the project has been set up is possibly incorrect, and then that needs updating. So it informs and enables the organisation to target the data quality efforts.
Oh, good. And just I guess one more question. Obviously, the original submission, C55 submission to this competition was made, well, actually quite early last year. Have there been any, or what have the developments been in terms of activities associated with the system that may have enhanced the product over the last 12 months or so?
There have been a number, quite a few. So there's the evolution of our cost estimation platform to bring in and utilize cost models in building in investments and being part of that cost management life cycle. There's a capture module which enables investment sponsors, for example, to scope investments outside of the main system and push them to the system themselves. And so you could possibly either visualize where the assets are and start to pick the assets you need to scope up an investment. And there's our predictive analytics area of the Copperleaf solution has evolved. So this concentrates on asset optimization and looking at a long-term view of the asset life cycle, and it enables an organization to also incorporate any investments projects that it has targeting assets as part of that optimization. So the system will know, actually, we're already targeting this, and so we can take that into account when generating the value. So those are, to name but three, as well as the ability I mentioned earlier about the value framework. We have an enhancement now where we can visualize our value framework and actually give the ability for a user to make edits to the models using our framework designer. Excellent.
Demetrius, I think that's probably all we have time for, as they say. So thank you very much for your presentation. Apologies for the technology bit, but we'll get the slides out in due course. Brilliant. And wish you all the luck with the upcoming award and celebration on the 18th. Thank you very much for your time.
Thank you.
And good luck in the future with your product. Cheers.
Thank you. Bye-bye.
Excellent. Thank you. So just moving on then, ladies and gentlemen, to our second speaker, who is Alex Stewart from SGN. So Alex has nearly 40 years experience, hard to believe, Alex, in the gas industry. He's been working directly in the innovation field for over 10 years. Alex joined British Gas Scotland back in 1981 as a student technician engineer on a 4-year training programme, due for completion any day now, I'm sure. Following a varied career, he ended up managing teams, dealing with gas escapes, repair and replacement programmes, working in Glasgow, and then he joined SGN when it was formed back in 2005. So Alex is going to talk to us about Microstop, which was a collaboration between SGN and Pipeline Technology Limited. Microstop is an innovative flow stopping technique allowing work to be carried out on live network risers without the need to isolate or disconnect customers. So with that introduction, Alex, hopefully you can show your slides, and it's over to you. Thank you.
Okay, thank you. So, yeah, as was said, we had a a collaboration with Pipetech. I'm going to go through the process that we did and then talk to you about some of the issues that we had, and why we approached the project the way we did and the outcomes of the project when we actually got there. So just to give you a brief overview, the SGN's got about 188,000 risers at the moment, feeding all sorts of buildings. From the 3-storey tenement buildings in Scotland built round about the mid to late 19th century, through the high-rise buildings in the 1950s and through to the modern high-rise flatted properties and in non-domestic industrial properties. Most of the risers historically run internally through the buildings, and that causes us issues for access. And during emergency replacement or survey activity work, which we're obliged to do every 5 years, we identify work that needs to be done in these, whether that's maintenance, repair, replacement, disconnection. The bulk of this work is going to end up in having to disrupt the customer in one way or another, whether that's actually accessing the premises, disconnecting or interrupting the gas supply. So there's some issues in there that we identified as being major issues. It's the access side of things, it's the disruption for the customer at the end of the day, and it's the cost for actually doing all this. So some common issues with riser work that we've got from our operations guys. So again, as I said, customer access to individual properties. If we have to do any work in those properties, it invariably involves altering pipework and meter positions if we're renewing the supply. There's the aesthetics of conventional replacement. We've had a few projects recently in Glasgow and in London where we've done some work in what's classed as historic areas and conservation areas. So that has an impact with the planning departments. The need to interrupt the supply to complete the work, as I said, that's always an issue, especially when you've got multiple customers. Access to turn the customers off and back on again, resulting in customer inconvenience. So it's not a one hit. We might be in the customer's house 3 times, 4 times, disconnecting, reconnecting their gas supply before we eventually finish, which can result in access problems. So they may not be able to give us access all the times. So that results in access out of hours. We need to attend out of hours to restore supplies, reconnect customers, get the supplies back on. And that all impacts on the speed of work. Conventional replacement can take a number of days, from the smallest riser that might take you 2 or 3 days to a multi-story that can take you weeks. So we looked through the industry and we came across this product that was being used in Holland called Microstop, which was made by a company called Ravetti. And Pipetech are Ravetti's supplier in the UK. So we spoke to Pipetech. We thought, this sounds like an idea, looks like a solution to the issues that we've identified. And we got in touch with them and we raised an NIA project to look at the whole process, to try and take us through the certification of the process and the product and actually get to an end result where we could impact the issues that we've identified. So the project was split into 2 sections effectively. We had McCaw at that time, or Rosen as they are now, as the technical service provider. And we gave them a couple of remits. First of all, we asked them to look to see whether we could match any of the information from Ravetti up against our existing processes to try and do a mix and match to see where the gap areas were. That information was scant, to say the least. So we then resulted in us doing a quite considerable testing program on the product, and not just the tooling, but the fittings and its access and how we would deal with it and the processes that we would deal with it. Everything from pull tests, fire tests, flow tests, pressure testing, so that we could have some confidence that when we actually got to do a live field trial, or we actually used it live in the network, that it was going to work and give us that security supply that we needed. So we eventually got to that stage where we did some live field trials, and it started off fairly slowly in Glasgow, where we had, as I said earlier, we had a problem in a conservation area, in a Charles Rennie Macintosh-esque building that resulted in us having some complaints from customers when the initial pipes were run up during the mains replacement project. We went down, had a quick look at it, decided that we could do it much easier than the Repex solution was there, and actually hide most of the new pipework in the basement of the building, and effectively leave the customer with no change to the entry and the public areas in the stairwell. So we did 2 trials there. They went very well. We got some really nice feedback from the customers. One who actually thought that we hadn't done the work on site until he caught us the following day and we explained what we'd done. So that gave us some confidence as we move forward that this product might actually have some legs to move on. Very quickly, and even before I could think about where we went next with this, the depot themselves come up with a number of different solutions. And this was the prime example in the first place, where we wanted to renew the below ground section of steel, because that was the most at-risk part of the riser. And the sections of riser that we've identified, as I've already said, we do surveys on, and the bulk of these risers have an extended life availability still available. So this was the primary reason that we did this initially, was purely to connect a PE service back onto an existing steel riser. And whether that's the way the diagram shows here, or whether we look at trying to do an insertion through the existing supply, it meant that we minimised the amount of disruption within the building. As we moved on, the depots themselves quickly took up the mantle of this product, and they started to look at other things that were causing them issues. So they had repairs where we had damaged transition fittings at the entry of the buildings where someone had hit it with something. They had some repairs within the building itself where customers had drilled through the riser when doing DIY type scenarios. They had connections jobs that required a number of weeks notification to the customers to turn them all off, and that impacted on the customer service side of things. And all these, as we went through this, the operations side of SGN found a solution to that by using Microstop in various different ways to remove non-common materials from risers, and basically that had an impact on the customer satisfaction scores that we had. The fact that we didn't have to physically access customers' premises to do any of this work, the fact that we didn't have to physically disconnect the customer's supply, and then obviously the impact on all of that, as I've said earlier, is that we don't then have this issue where we have to send what are effectively emergency workers out of hours to common no gases where customers have been left turned off because we've had to do work during the day. So what we've ended up with after a number of tests and a number of field trials, and we actually did about 110 different field trials during the project itself, is a very safe, quick and effective way of doing the work on a riser that we need to do without having the impact on either the customer or ourselves. Gives us a much quicker solution where we can effectively complete the job in a matter of hours rather than days, without the need to access the customer or without the need to turn the gas supply off at all. So summary of Microstop, it's a very quick solution to riser replacement, repair or connections work. It's tested off-site and on-site and approved for use within the SGN network. And we've actually rolled it out to both Scotland and Southern, and they're actively using it in their day-to-day operations. It doesn't require access to the customer premises or alteration to the internal pipework. There's no requirement to isolate supplies or interrupt any customers. It's a much quicker and cleaner than a conventional technique, and it's more aesthetically and acceptable in common areas than conventional replacement or repair techniques. And I'm happy to take any questions from that.
Well, that's excellent. Thank you, Alex. And just by listening to your presentation there, I can see some of the obvious benefits that you quite rightly highlighted. So just a couple of questions then. First one is around sort of monetary value. Could you put a monetary value? You spoke a lot about customer service.
Yeah.
Let's say a monetary value to the benefit of Microstop.
The monetary value is a difficult one because it obviously depends on the scenario. And as I said earlier in the presentation, we've got so many different types of risers. We predominantly did the field trial in Scotland at the beginning on risers in the sort of early 20th century building type scenario. And we would suggest that on that, you're probably saving in the region of 30 to 40% of your standard riser cost, and that goes up considerably depending on the riser scenario. If you're not having to do external high-rise scaffolding, then obviously there's a major impact there on both the timescales and the cost implication.
Yeah, and you may have covered it, apologies if I missed it, Alex. In terms of sizes, does this take sort of 3/4 up to 2 inch?
No, it's 1 inch to 2 inch at the moment, so it's inch and quarter, inch and a half, and 2 inch. The product itself, actually, there is a 3 inch variant of it, which we haven't field trialed yet, but I think that's something that our operations guys in the south are actually actively looking at developing and moving on as well. So the full size range for the product at the moment is 1 inch to 3 inch.
Excellent. And just in terms of obviously the submission to the Product of the Year Awards was over a year ago now. Has there been any further developments during that time, or is it very much business as usual as a piece of equipment?
It's now very much BAU within the business. We're undergoing some changes in the operations field, and we actually now seeing that becoming more actively used across the networks as well. So we're not only looking at it internally, but also now actively promoting this to any of our external contractors as well, some of which have seen the product in use and are very keen to move on that, which is interesting. It's an interesting discussion to have with them. I mean, they obviously see some benefits from their side of things too.
Excellent. Okay, so I think that's about it in terms of questions, Alex. Thank you ever so much for the presentation. Thankfully, the technology worked for us in terms of the slides.
Yes.
And good luck in terms of the awards. Obviously, we'll hear the results on the 18th of May. So good luck with that. Thank you very much for your time this afternoon, and good luck with your products in future.
Thank you very much.
Thank you. Okay, so moving on to our third speaker then, which is Andrew Sparks of Synthotech. Andrew is Customer Relationship Manager at Synthotech. Got a bit of background noise there. It must be you, Andrew. Who joined Synthotech back in 2009. Andrew is going to talk about ServiceCam, which is an unpretentious, small diameter, live access CCTV system, but it has a big impact upon, apparently, so we'll hear all about that, I'm sure. ServiceCam was specifically designed for 17.5 to 32 millimeter PE or Serviflex lined services and 3/4 to 2 inch metallic services. Excuse me. So with that, Andrew, it's over to you. Thank you.
Thanks for the opportunity to present to you again. I'm Andy Sparks, Customer Relationship Manager for Synthotech Limited. I'd like to talk to you about our great small diameter live access CCTV system that has made a big impact in the gas industry over the last 5 years, namely ServiceCam. ServiceCam was initially developed during project work with SGN for the potential of live Serviflex insertion. Within that project, the use of a small camera head to see the inside of Serviflex lined services really captured the interest of engineers in the field. From the initial camera used on the project, further work was undertaken to design a camera that would be able to survey up to 20 meters of either 20mm PE or Serviflex line 1 inch service pipes at pressures up to 75 millibar. The first service camera, launched in late 2015, was ergonomically designed to be a one-person operation and to be able to navigate up to 2 90-degree bends in PE line services and up to the first bend in metallic services. The kit comes with a bespoke 9.5mm camera head with shortened focal length due to the size of the pipe it will enter. It has 6 LEDs to illuminate the pipe and a spring to allow bend navigation. The picture from the camera is viewed on a compact and functional ServiceCam display unit, which is battery powered for up to 5 hours use from full charge. For charging of this unit, a 240 volts main charger and 12 volt car charger can be used. There is a low power indicator on the screen, and if recording is required of any footage seen, then the camera call can be linked to the SKU recordable unit, which is part of our main survey kit. The insertion system is suitable for both 1-inch and 3/4-inch ball type ECVs. The insertion system will screw directly onto a 1-inch BSP thread with MSEX adapters available for 3/4-inch. In terms of glanding, for the ServiceCam is made up of 5 elements, 3 rubber seals and 2 O-rings. Silicone grease should be used sparingly to help the camera head through the rubber elements prior to survey. Since its launch, the benefit of this product has given to the gas distribution industry has been immense. From quick and effective fault finding on 1-inch line services to rapidly identifying poor pressure to a property, finding obstructions or water in the pipe, being able to quickly trace the line of a service pipe and locating mains connections for build-overs and GSMRs, cost savings from no excavations on expensive customer driveways, and reducing fault-finding works by over 2 hours. Listening to feedback from the gas operatives using ServiceCam, the second version was developed with a tighter spring to ease the distance pushed and also reduce snagging. And when used in conjunction with the specially designed survey guides, this enables the camera to navigate up to 3 metallic bends in metallic surfaces from 3/4-inch up to 2-inch. The increased functionality these additions had given means ServiceCam is the first tool out of the bag when finding faults on services. Synthotech's international distributors soon began to hear of the success of ServiceCam in the UK gas market, and opportunities arose for the third version of ServiceCam to develop, allowing surveys to be completed at up to 4 bar in pressure, other new additions of a new enclosed lock and reel frame for easier unreeling inside properties, and meterage shown on the display to pinpoint the exact location of an issue were incorporated. Ireland, Colombia and Australia are now avid users. As an example, in Colombia, the 4-bar system is used for investigating potential gas theft and can easily detect where services have been tampered with. ServiceCam in this particular country paid for itself on its first job, where an illegal bypass had been added to the service, saving the gas transporter untold amount of lost revenue. Just to confirm, the ServiceCam range now includes the ServiceCam Lite for PE only, ServiceCam PE and Metallic, and ServiceCam Pro. Every picture tells a story. On this slide, here a repair team using ServiceCam were able to find that a PE pipe had been damaged by a tree root that had wrapped itself around the service. After accurately locating the problem, the team were able to precisely excavate and carry out repairs in a matter of hours, saving time and over £1,000. Other examples of poor pressures being caused can be seen in the above pictures, from incorrectly inserted Serviflex pipe, damaged PE services, and an obstruction such as swarf and even snail. Throughout the 4 gas distribution networks, there are numerous examples of how using ServiceCam can save the network money. From locating and pinpointing services on DR4s, reducing the amount of time on site and eliminating misdigs, saving on average £1,250 per job. On GSMR, ServiceCam was shown to save over £227. A built-over service was surveyed and located within a new driveway, reducing the disruption to the customer, and was shown to save £645. And then a blockage in a steel service pipe under a new driveway was shown to save £450 by reducing the equipment and personnel required on site. This is just to name but a few. The footage in the video above where both PE and Surfiflex lined pipe have been damaged and water has ingressed into the pipe, forming water globules and white marks from water being inside the yellow Surfiflex pipe. This gives the repair teams chances to do the repair work and make informed decisions. Synthotech, as part of an NIA with Northern Gas Networks, developed a water extraction service cam after this to be able to get the water out of the service at the same time. Recent customer satisfaction surveys of the networks have given ServiceCam a 4.9 out of 5-star rating. And now that ServiceCam can survey both metallic and PE pipes, it has become the go-to piece of equipment to save time and money when looking for issues relating to service pipes. The feedback gained was that using ServiceCam saves on average 2 hours per job and is used on PE services 2/3 of the time. All 4 networks have seen the benefits of investing in this uncomplicated and easy to use one-person traceable camera, highlighted in the numbers that continue to grow across the country since its first introduction some 5 years ago. And in conclusion, the benefits of ServiceCam include emergency response and fault finding, investigating obstructions and pressure problems, locating defects and water ingress, and locating service interchange from Surfiflex to straight PE without excavation. And that's it. If you need any further information, please feel free to contact us, and happy to take any questions.
Brilliant. Well persevered, Andrew, and thanks for rejoining us. Appreciate many people had to close at about 3 o'clock, so a few people have had to leave us. So just a quick question, I guess, in terms of, sorry, that's an interesting screen pattern. So just in terms of, you still there, Simon?
I'm still here. Can you hear me?
Oh, right. I've got a, what did you like about this event? Thanks for attending kind of screen up. I guess just a question actually, Andrew, is the kits either supplied, is there a lot of training involved to the for teams or users?
Yeah, there is training. It's only a couple of hours training that's required. It's just to go through safe insertion of the camera, because obviously it's going into live gas. We generally would train, before COVID, we would train 6 operatives in a classroom basis on a designed rig, and that would take approximately 2 hours. But obviously, during COVID times, we've actually developed a video online that can be used to do the training.
All right. Okay. Well, hello everybody. Apologies. Seems that we've lost Andrew there. So just bear with me. I think Duncan's now able to join us, which is good. So I think what we'll do, if we do get a chance to get Andrew back, well, we'll do so. But other than that, we'll perhaps just have to move on now to our final speaker. So let's hope that Duncan can hear me. So Duncan is the technical support manager from Plasson, where he is responsible for product development, technical support, marketing of cutting-edge pressure management solutions, training for end users and the company's own staff, utility contract tendering, managing relationships with subcontract manufacturers and with the standards institutions, both for ISO 9000 and 14001 systems. Does that all before lunchtime on Tuesday, apparently. So Duncan's going to talk to us about the Plasson mechanical purge end fitting, developed in collaboration with Cadent Gas, with guidance from ROSEN UK. Now, this is a purge end temporary fitting. It's intended to replace the conventional electrofusion end cap with top-tier arrangement used for pressure testing and purging of mains, which normally, of course, will be cut off before connection and then discarded, of course. So with that introduction, Duncan, hopefully you can still hear me. Hopefully your slides will work. I'll hand over to yourself. Thank you.
Good afternoon. My name's Duncan Fisher from a company called Plasson, and I'm here to tell you a little about a project with a purge elbow. If I may, I'd like briefly just to introduce Plasson as a company. We're not particularly well known in the gas industry in the UK, but we have been around for a long time, having been established in 1963. We're a global business with over sales into over 100 countries on 5 continents, and a turnover in 2019 of about $420 million. So we have, shall we say, a little bit of history. We were invited to look at a project related to purging of gas mains, and for those that are not familiar with the process, a brief outline is that a new main needs to be filled with gas, but it does need to have the air removed. It is a safety measure prior to actually commissioning the line for use. The purging operations, typically on polyethylene pipe, involve the use of a welded purge tee and an end cap welded onto the end of the polyethylene main. The purge tee has only one use, and that is for removing air from the line. After it has been purged, approximately a metre of pipe, the end cap and the purge tee are typically cut off and scrapped. And annually, that's in the region of 200,000 units that are being scrapped. And the challenge was to reduce the environmental footprint and the costs of the purging operation with a simple but reusable solution that was easy to implement. Our partners in this were Cadent and ROSEN. Cadent actually commissioned the project, and ROSEN were deeply involved in the technical aspects of specification and of the actual testing of the system. In project history terms, we started when the basic outline was identified by Cadent in 2014, and for the next year we worked on a prototype of a purge saddle that was reusable. Having developed and field trialed some prototypes, it was decided to change direction, and in 2015 to 2018 we developed the range of fittings that are in the pictures to the right there for both purging and for temporary bypasses. And these have been in use now for a number of years very successfully, but they still are based on a top tee welded to the main. It's a standard top tee and not dedicated to purge, which means it could be reused for the final domestic tie-in, but it still, in a lot of cases, was sacrificial. So we, after getting partway through the project on this, reviewed it, and then in 2017 started work on a project to develop an alternative solution which had actually no sacrificial part whatsoever. It was an NIA funded project and now has been concluded. The product performance specification was written by ROSEN as a follow-on to the previous work that we had been working on. The concept was initially tested, full laboratory testing by ROSEN, and then a field trial with Cadent staff was conducted by ROSEN. There was analysis of the fittings after use in the field. Having recovered them from the field after multiple uses, we retested them and analysed that retest result. And we also took in user feedback from the men in the field who had actually used the fittings. There was also a need to develop an appendix to PL3, which is the specification for mechanical fittings for use on gas mains. And an Annex P has been written for temporary use fittings, which I believe is due for publication shortly. The Noa Closure Report was issued in February of this year. Essentially, a purge end fitting is reusable. We reckon that in excess of 50 uses would be easily achievable. The advantage of this approach of a temporary use fitting here is that each time it is used, it is tested for integrity before a gas gets anywhere near it. So you have a high degree of confidence that once the fitting has been assembled on the pipe and tested, that you will have a very satisfactory outcome. There are two seals that seal inside the bore of the pipe, which escapes the problems associated with sealing on the outside, which can be damaged on this sort of pipe where it has been inserted through an old main. The joint is end load protected for security so that it won't pull off the end of the pipe, and is estimated that it will pay for itself within 5 to 10 uses, depending a little bit on how you calculate it. One area of potential saving that hasn't been quantified, but which we believe will be of value to the industry, is that it has the potential to reduce the excavation size for the receiving pit when you're doing a pipe push through an old main. Currently, you need quite a lot of space to allow for all the bits you're going to purge through and then cut off. This approach means that there is no pipe cut off, and as a result, the excavation can be smaller in physical size, which has a benefit. It's less digging and obviously less refilling afterwards. There is no plastic waste from this type of purging methodology, so the waste stream is much reduced, and it's easy to use. Only hand tools are required. You don't have to log on to anything, so it's very human in its approach. From the assurance point of view, it meets the GIS PL3 and Annex P specification. It reduces the costs of the application. The job of purging actually becomes cheaper because you are reusing a fitting, and you also have the associated benefits of the footprint reduction from the excavation and the environment benefit from plastic waste reduction. Quite simply, a reusable fitting is suited to use in this particular type of application. It's tested before every use, so there's no need to track the fitting for its number of uses. This was considered during the project, but the sheer difficulty of trying to manage tracking of a fitting was not practical. But because it is tested before every use, you do have that check that everything is secure from the moment you commission it. Dual seals are there for long-term integrity. To be sure, as they say. Simple tools and quicker processes. You don't have to spend time dragging your electrofusion control box up to the pit and welding things on and allowing for cooling and all the rest of it. It is a matter of fit it and use it. From the installer point of view, it's not exactly rocket science. You slacken the nut off, you push it onto the end of the pipe, you tighten the nut, and that is basically the abridged form of installation. Very simple. As I mentioned before, the mountain of waste that was created by cutting purge tees off is eliminated. We all know the sensitivity of plastics in the environment currently, so the more we can do to remove it, the better. And there are significant financial savings, both in the reduction in costs of the consumables used in the purging process and reductions in the cost of waste disposal, not to mention the reductions in excavations and reinstatement. So the product itself is very simple. There are 4 sizes. 63, 75, 90 and 125. And they are reusable until well, sufficient damage has been done that they fail on test. And we confidently expect there will be fittings that will be used for 100 purges before needing replacement. So it is a significant benefit from the point of view of costs for the task, but also it makes it much easier for the guys doing the job. And the feedback generally from the staff doing this process has been very favourable, to the extent that they want all 4 sizes available tomorrow. We are in a position where we are getting the first stock in the next 6 weeks, and we'll be rolling it out to the first users in Cadent post-trial shortly thereafter. It's a simple process and available, as I say, very shortly. We have a question about training of the operatives. It is a very simple fitting to use. The complete process has been videoed with instructions, but we can provide separate instructions. And simply the pipe end has a very small bit of preparation to remove the sharp edge of the internal wall of the polyethylene. The fitting is lubricated with your standard lubricant fluid. It's slid on to the fitting, onto the pipe end, and the fitting is then tightened with a pair of wrenches. The fitting is then pressure tested with the old soapy disclosure fluid, and that is basically the job. To remove, the gripping components have been engineered so that they will open as you release the tension on the nut, so that you should be able to just undo the nut and pull the fitting off after use. Once the fitting has been removed, you can then prepare that pipe end for an electrofusion coupling to couple up the next piece of pipe. So actual training of operatives is quite intuitive. It's a simple process. At the moment, we have deployed these through a field trial within Cadent. The results of that field trial have given Cadent the confidence to place a substantial order, and the expectation is that this will become Cadent's standard methodology for purging gas mains. It's not going to be rolled out to everybody the same week, but will be a progressive introduction over time, purely because the resources to train and manage the implementation need a little bit of planning.
Duncan, can you hear me?
So that, unless there are any other questions, concludes my presentation. I would like to thank you for taking the interest, and many thanks for the organisation and being invited to present.
Thanks, Duncan. Unfortunately, I don't think you can hear me. Hopefully, the rest of the audience can. So we're pretty much finished in terms of time. So really just leaves me to wrap up the session. So many thanks to all our speakers. Apologies to Demetrius in terms of the technology, and of course Andrew, who I think unfortunately had to got disconnected somewhere. But thanks again to Demetrius, Duncan, Alex and Andrew. To find out who wins the Morrison Energy Services sponsored Product of the Year award, please join us on Tuesday the 18th of May. Invitations to a laptop near you, no doubt. And that's for this year's EUA and IGEM Gas Industry Awards ceremony. So we'll be continuing to look at this year's finalists next Tuesday, where you'll be hearing about the 4 finalists for Project of the Year. And who knows, you may hear the Morrison brand crop up again next week. So that's it for now. Thank you all for joining us.